So this is basically an AP physics problem based off conservation of energy as well as kinematics. A block slides down a smooth track from P to Q when it's released from rest. It then slides on a rough surface of coefficient of kinetic friction equaling 0.25. How far does it slide before coming to rest? So what details we've been given here is the height of the block initially from the reference level, the surface level is 3 meters. It slides through a smooth track having coefficient of friction 0, and then it comes and slides on a rough track having coefficient of friction 0.25. So initially let's take the potential energy of the block to be equal to 3 mg. We do not know the mass of the block, therefore P is equal to 3 mg. We can take G to be 10 here for calculation purposes. Therefore, this is equal to 30 m. We know that after it comes to the point Q, it's going to be having zero potential energy. This is because Q is at the reference level and therefore height measured from it will be 0. Therefore, the formula mgh would be 0. Therefore, it's totally converted to the kinetic energy at that point, which will be 1 by 2 mv squared, where v is the velocity at that point. So, m and m cancel out here. So, then I would say that we will be getting that 60 is equal to v square, and v would be equal to root of 60 meter per second. But again, we wouldn't be needing the value of v here, we would just be needing v square. As the problem goes on, we realize that. So I just keep it as v square is equal to 60. Now the second part of the problem is going to involve kinematics. First, let's take the formula of the frictional force. Frictional force F, or let's say small f, is equal to the coefficient of kinetic friction times the normal reaction. The normal reaction, again for an unknown mass, we can only take it to be in terms of g. Therefore, it's going to be equal to 0.25 into 10m. This is going to be, because 10m is the normal reaction. If normal reaction is going to be the weight of the object, that is the force mg that's going to be acting on the object. Here we can take, therefore we can take this to be 2.5 m to be the frictional force that is acting against this object. But here the catch is we don't need the frictional force, we need the frictional acceleration. Therefore acceleration is going to be 2.5 m divided by m, as f by m is acceleration. Therefore it's going to be 2.5 meter per second squared. But here it's going to be negative 2.5 meter per second squared. This is because it's going to be opposing the motion there. If the velocity is going to be positive, keeping rightward as positive, it's going to be opposing the motion. So what we have here is, now we'll just apply the third equation of motion. 2as is equal to v square minus u square. We have v square, we have u square, we have a, and what we need to find is how far does it slide before coming to rest. So we get s. So here we can rearrange this to be v square minus u square by 2a, which is going to be, v square is going to be 0, minus u square, which is going to be minus 60, divided by 2 into minus 2.5, which is going to be minus 5, which is going to be minus 60 divided by minus 5, minus cancel out, is going to be 12 meters. So using the property of conservation of energy as well as using the kinematics, the third equation of kinematics, and the formula behind coefficient of friction and frictional force, using 3 steps we have solved this question, and 12 meters is going to be the distance the block travels before it attains rest once again.